Hello and welcome to another session of AP Computer Science A. Right now I'm going to show you how to employ methods in the MostFactors lab. Now, you've all made the MostFactors lab. And if you look over here on the left, you can see the MostFactors lab description. In the MostFactors lab, you have to write a program that gets a number from the user. In the first example, that number is 25. Then it finds the smallest number that's less than or equal to 25 that has the most factors. In this case, it's 24, which has 8 factors. For 17, it has 6 factors. So we're going to make this lab again, and this time we're going to use methods, and you'll see how methods make the program more modular and easier to create. So I'm going to start over here on the side. I'm going to take this blank Java. I'm going to drag it into my source folder. When I do that, it's going to copy a blank Java into the source folder. And this gives us a blank canvas on which to start. Now you could also use a new Java class to make the Java class using the wizard. But the wizard is going to add stuff that I would like you to get used to knowing so you can write it in your sleep. So we're not going to use the wizard, we're going to use the blank instead. So I'm going to open up the blank Java. And we're going to make a lab for the MostFactors lab. I'm going to bring MostFactors to the top again so we can see it. So in the MostFactors lab, the name of the class is going to be MostFactors. So I need to change the name of my file to MostFactors. So I'm going to do that here. To change the name, you right-click on the blank Java file, and you refactor, rename. If you've already started a class and the two don't match, the name of the file and the name of the class don't match, then you can change it using rename, and it will change both. MostFactorsMethodsDemo. So now we see that the name of the file changes, none of the innards change. So I always like to start doing the top-down programming by giving comments on what this is supposed to do. MostFactors, it takes an int from the user and finds the int less than or equal to, the user's number that has the most factors. So now we've seen this before, and we know that there's several parts. We need to get user input. We then need to do math, and we need to print factors. And when we're done, it should look like this. We'll just copy the description from the examples. Oops, we can't. And paste them in there. So /*, enter. I can't see it, so I'm going to move this over. There it is. There we go. Enter a number. User gives a number, and then we see number is the smallest number that has blank factors. And then we print out the factors. So that's what the output is going to look like when we're done. And we can get main done. So we're doing top-down programming. In top-down programming, you break a big problem into smaller problems. So let's make our class first. The syntax for a class is public, which means everyone can use this class. Class is the keyword that starts a class definition. This class has to be the same name as the file name, which is MostFactorsMethodsDemo. Class has an open curly brace. Eclipse will automatically close it with a closing curly brace for you, so we see the start and end of the class. And in the middle goes all the class information. So in this class, we need a main. So as you've done before, public, static, void is the return type, main, and the parameter list. String, array, args. So let's walk through the main syntax. So the signature of a method has access control, then a return type, then the name, then an open parenthesis, then a parameter list, then the closed parenthesis, and then the curly brace. And we see that the main function follows this pattern. Access control, return type, function name, open parenthesis, string square brackets for parameter args. And in main we want to do two things. We want to take an int from the user. So I'm going to copy this and paste it in here. And we also want to do the math. Oh, here we go. Do the math. And the last thing to do is print the factors. So we take an int from the user. Int user's number equals get int from user. Do the math. What do we want to do the math for? In the math we want to, oops, something's wrong here. In the math we want to find all the factors. We want to find the most factors and then print them. So we're going to do int array factors equals find most factors from the user's number. And the last thing we want to do is print them. So we're going to do print factors, the factors. So we've broken our main problem, do the whole program, into 3 steps. Get integer from the user that gets the user's number. Then we find the most factors, and here I'm going to use an array of ints. We didn't do this before. And an array of ints will have all the factors in it. We can figure out how long the array is, and that'll tell us how many factors there are, and we can find out what number created those factors. That's the last number in the array of factors. So find most factors is going to return an array of factors, and then print factors will print those factors. So the next step, I have made 3 function calls. These functions don't exist yet. That's why they have this red underline. So we need to make those 3 functions, and then we can test our main. So as always, when you're doing top-down programming, test early and often. And to do that, you make a step, and then you run it. So here the first step is to make main. I've made main. Main does not run yet, so I need to make the 3 functions for main and then test to see if main runs. So in the first function, I get int from users. As always, this is a function signature. I need access control. This is a public, or let's make it private. This is a private function, which means only main can call it, or other functions in MostFactorsMethodsDemo class. It's static. Static means we do not need an instance to run this function, and we'll talk about instances in the next unit. The return type here is an int. The get int from user is going to return an integer and put it in user's number, so it must return an int. The name of the function is get int from users. The easy way to put the name, because the 2 names have to be exactly the same. So I'm going to double click on get int from users. This selects the whole name. Control C to copy. Control V to paste it here in the signature. Open parenthesis and close parenthesis. There are no parameters in this function. Open curly brace starts the function. Eclipse automatically gives me a closed curly brace. We want an int, return number, and then we just return that number. Return number. And let's set this return number to a fake value. We're going to set it to -999. So -999 is a fake value saying we haven't fixed get int from user yet. But now get int from user will actually run. It creates nonsense, but it runs. And what we want to do here is test my main. In order to test a main, I have to have 3 running functions. So now get int from user should run. It doesn't work, but it runs. We want to do the same thing for find most factors and for print factors. So let's do the signature again. Private means that only main can run it or any other functions in MostFactorsDemo. Static means, again, we don't need an instance for this. The return type here is an int array. And the name of the function is find most factors. It has a parameter list. In the parameter list, it's going to accept user's number. User's number is an int. So it needs to send an int in here. And we'll call that user's number again. Now, it doesn't have to be the same name. So I can call this user's num to show you that the name that you pass into a function need not be the same as the parameter's name. So the value in this variable would be put into this variable when the function is called. Open parentheses starts it. We need a return type. So the return type is an int array. So I'm going to make an int array. And we call this the return array. We're going to set it to null, which means it doesn't exist. And then we just return it. Return array. So now find most factors will run. We see it's running here. It also does not do anything. The last thing I can do is print factors. I need all three functions to run. It's a private, static. It has no return type, so the return type is void. Void means it doesn't return anything. The name of the function is print factors. It takes as an input factors, and again we see up here that factors is an int array. So we take an int array as input, int array, and we'll call this factors. And so this is a printer. I actually want to see something when I run this, so I'm going to do a print here. I'm going to say system.out.println to do print factors. And all this tells me is that print factors is not ready yet. So now everything should run. We should be able to do our first test. I'm going to run the first test. And to do print factors, so it doesn't break. So the main works, and all the little stubs, a function, a method that runs but does not do anything is called a stub. So these are stub functions. The stub function is sort of the bare bones of the function. It's the framework. It runs, but it doesn't do anything. It's not finished yet. So now we're going to finish some of these things. The first thing I want to do is I want to get the int from the user. So as we saw before, in get int from user, we're going to write down what it does. I'm going to do /**, and hopefully it works. It does not work for me. How about /*, enter. There we go. So if you do /* above a function name, this will put a multi-line comment for you. If you then call this function from some other location, you'll see the multi-line comments that you write. And so this is a way to tell the user who's going to use your class what your get in from user actually does. So here we're going to say get in from user, and a one-liner of what this does. This gets a positive integer from the user, and if the user is not cooperative, repeatedly prompts the user to enter the correct values. So as you know, users do not have to pay to behave, and they could type hello world instead of a number when you ask for a number. So get in from user. Let's break this down to the things we need. We need to get an int from the user. And in order to get an int, we need the scanner and an int to put it in. We have an int to put it in. We also need to convert from a string to an int, and we need to get a string as well. Get input, a raw input, into a string. And then we need a loop. So we get the scanner and we do a loop here. Loop until correct. And once we're done, then we return the int. and close, I'm sorry, before we return the int, we have to close the scanner. So here I'm planning what to do in my function. I have my integer to return here. It's called return number. Right now it's been returned, but return number has a fake value in it. And what I'd like to do is get an int. So I need a scanner. Let's do that first. To get a scanner, we're going to create a scanner. Scanners are called scanner. You can find a scanner in Java utilities. We're going to name this something. I'm going to call mine input scan, or iScan. And we're going to set it to a new scanner. And a new scanner is system.in. Now, all of you have done this, so this should be familiar to you. The one thing here we see is the scanner is underlined. That means that my program currently does not know what a scanner is. So I need to tell this program what a scanner is. And to do that, I'm going to import the scanner. The easy way is to hover over the scanner, and you see the first line says import scanner from Java util. If I click on this, Eclipse automatically writes the top here, import Java util scanner, and this will actually find the scanner and get it. So we want this line. Now in the AP Computer Science 8 test, you will not have Eclipse. You'll have to remember everything from rote memory. They won't really look for this to ding you, but it's good to know it's there. So now I have a scanner in there. We see that the orange lines under the scanner have disappeared. I see a yellow line under iScan. This means that iScan is not used yet. Once I use the scanner, I need to close it. So on this line, I see close scanner. So let's close that scanner. iScan.close. And I will need to do all the input from the user between when I open the iScan with new scanner and when I close the iScan with iScan close. iScan close closes the system.in at the same time. And so there's a mess. I haven't figured out how to reopen system.in. So please only close when you are finished. With the scanner. All right, loop until correct. So we have three kinds of loops we can use. We have a while loop, we have a do while loop, and we have a for loop. And the best one for this purpose is the do while loop. The do while loop will do the whole loop first. So we're going to get input from the user first, and then we're going to see if it's broken. A while loop will check to see if it's good, and then get stuff from the user. So we want to do a do while loop. And then the for loop is usually used to iterate through an array. So do while loop has the following syntax: do, an open curly brace. We're going to get raw input inside the do and convert it to a string. That goes inside the do. And when the do is done, we're going to do a while. And this is while we need input. So we're going to say need input as a variable. And so we want a variable for this do while loop. It's a Boolean need input, and we're going to say this is true. So as long as need input is true, we're going to keep asking input from the user. And once we get good input, we're going to change need input to false, and that will end the do while loop. So now do get raw input into a string. That's easy. We cannot go raw in here, so we're going to create a string to put the input in. Let's put the string outside. String raw input equals the empty string. And then we overwrite raw input with what the user gives us. So we use the scanner, iScan. The scanner has a whole bunch of methods that you can use. If you use a period, you see all the library methods. And the one we want is get, and I don't see it. Oh, equals. I need an equals here. There we go. Much better. iScan. Much better. We want next line. If you hover over one of the different patterns, you click on it once. Next to it, the yellow will tell you how it works. We want next line. Next line gets a whole line from the user, including the return. And you've used this before. So next line will get all the characters the user types and stick them into raw input. So the user cannot break next line, but the user can break the next one. We want to convert the string to an int. And if the user can break something, then we need a try catch loop. So let's put that in comments. User can break here, so put in a try catch. put in try catch. So the try catch syntax is try, open curly brace, and we're going to catch an exception, catch whatever that thing can do. And so to find out what kind of exception comes out, you can go to the function that might break, click on the name, and find down here it says throws, no such element exception, and illegal state exception. So it throws two types of exceptions. Both exceptions have the same kind of base class, which is exception. So we're going to cast an exception, E. And that'll catch both kinds of exceptions, and this will prevent the operating system from terminating our program. We'll catch the exception first before the operating system does, and terminate the program. So if we catch anything, the user is screwed up, we want them to input again. Need input equals true, and we want to tell the user they screwed up. System.out or .println, please enter just an integer like 15. Let's put 15. All right, and so here the user need input, not need to input. Notice that if you use a variable, it has to be the same name as when you create it. This will ask the user, I'm going to shrink this welcome screen. So notice here that if we get into the exception, the user has done something wrong with the convert from string. So they probably did not give us a string to convert. We have to tell them, please enter an integer. We also need to prompt the user to give us something. So I forgot that up here. Prompt user to enter a value. So we're going to do system.out.print. Please enter a positive integer. Please notice that I used print and not print line here because I want the cursor to end right behind the prompt. So the user will add their variable right here. Also notice that I have changed the prompt from what I asked for in the description. Enter a number to a more descriptive, please enter a positive integer. So the user sees this. The user is going to enter a positive integer, hopefully. We convert to a string to an int. So we have this string, raw input from the user. In the try catch block, we're going to convert the string to an int. And to do that, we're going to use the integer library. And the integer library has inside it a parseInt function. A parseInt will take a string, this is raw input, and try to convert it to an integer. And the integer we want to convert it to is whatever this thing is called. What's it called again? Return number. Return number gets what comes out of parseInt. So this can break, and if it breaks, we catch the exception. So now I'm not done with my do while loop. Let's make this a positive integer. So now if the user has missed the catch loop, they've entered a valid integer, but a valid integer can also be negative. So we have to test it. Did the user give us a positive integer? And we can find this out with an if then else statement. So an if, and the conditional is, here they've added a number, return number. I need to do something else. I need to do a continue here. So I haven't told you what continue means. If you see a continue, that means stop doing any code in this loop and go back to the top of the loop. So continue will go back to the top of the loop. And this way we're skipping the if statement. If the user does not give us an integer, we go back to the top and keep going. If the user gives us a return number that is too small, is less than or equal to 0, that means a negative integer, then we're going to ask them to give us a positive integer and return. And so we're going to ask them, please give us a positive integer again and continue. And then if they've made it past this, then we're done with the while, Also, I'm sorry, need input needs to be true here. And otherwise, we're done with need input. So if we are finished here, need input can be false. So if we get to this step, we're done with the while loop. So let's take a look at this while loop one more time. 52. Okay, so I have about 20 minutes left. If we look at this while loop again, we're doing input validation. Say do while. We're going to do as long as the while is true. So we keep doing the loop as long as the while is true. Need input starts true. I ask the user to give me a valid input. The user gives me something. I check to see if that's an actual integer. If it is, it goes to return number. If it's not, I get out of the loop and start over again. Then, if the user gave us a positive integer, I check to see if they did not. If the return number is less than 0, then the user gave me a negative or a 0 integer. We want a positive integer. And then we want to repeat the loop, so true. Continue will actually go back to the top. And then need input's false. Once the user gives us a valid input, then we have need input. We close the scanner and return it. So now we're ready to test this function to see if it works. And to test this function, I'm going to go back to MostFactors here and just print the number the user gave us. System.out.print line. You entered plus the user number. So now we're ready to test this. We have what we think is a working get int from user. And we're going to see if it works. So let's run this and see if it works. You can watch the output. Enter a positive integer, Mikey. Please enter just a positive integer like 15. Enter a positive integer, -8. Please enter just positive or 0 should also fail. And then if we enter an integer, it should work. 15. So it says 15. Let's put 15 in. You entered 15 to do. So that's working. So if the user goofs up and tries to goof up and break your program will not break. And that's why we do input validation. So now we're ready for the next part. If we look back at main, we have now happily got a user's number, and it's time to find the factors. And this was the tricky bit, right? Do the math, and then print the factors. So let's do the easy one first to make ourselves happy. We have about 20 minutes left. And we're going to have find most factors give us a fake list of numbers. And we'll see if we can print those out. So here's find most factors. Right now it's giving us null. Instead of giving us null, let's give us a fake list of numbers. So to give a fake list, we can use an initialization list. Initialization list is found between open and closed curly braces as values that you enter into something. So here we want to enter an array of numbers. And so the array of numbers would just be, say, 1, 2, 3, 4, 5. That's good enough. And so we have this array of numbers that should come out. And we want to print them, so let's get our printer working. So I'm going to get rid of this to-do print factors. And to print it, we have to see what we want the output to look like. We scroll to the top, we have our example output. Our example output is right here. Something is the smallest number that has something factors and print out factors. So I'm going to grab these two lines. So this is what I want to print out. I'm going to copy them. I'm going to move down to where I'm doing my printer function. I'm going to paste these comments right above the printer function and turn them into comments. The easy way to make inline comments or one-line comments is Control and then the backslash or the slash. This will turn what's selected into comments. Otherwise, we can by hand type the two slashes. So this is what we want print factors to do. It's going to print this exactly. So print factors. Oopsie. Outputs. Blank is the number. Is the smallest number, so we have some number here. Number is the smallest number that has number factors. And print out the factors, and we want to print out factor, comma, space, factor, comma, space, factor, comma, space, and so on. So now we know the format that we want our printer to look like, and we can make this work. I have a fake return value coming out, 1 through 5. So we should be able to print this out. So I want to say blank is the smallest number that has blank factors. So it's easy. System.out.print, and this is a print line. Did I do that right? I did do that right. Okay. open parenthesis, blank is the number. So that's at the end of this list. And that's at factors of factors dot length minus 1 plus is the smallest number that has blank factors, and that's how many factors we have. And how many factors we have is found in factors dot length. So notice that we have some new things that we're using here. We're using an array called factors. And factors and arrays have fun attributes. One is called length. We can find the length of the array, and we're using that. There are other attributes for arrays. You can find them by just typing the name of an array and putting a period, and it'll give you a list of things. But we just want the length that has blank factors. And then the last thing is to print the factors. To print the factors, we need a for loop. Oh, I'm going a little fast here. Oh, we have it out. Print the factors. For int f equals 0, the first factor. F is less than the number of factors we have, which is in factors.length. F plus plus. This will go through each index, and all I need to do is print out the factor with a comma. System.out.print. And we need the factor, which is in factors of f, and a comma. I do notice that normally you use open close curly braces and for loops. You do this if you have more than one statement that's coming out. And right now I just have one statement, so I don't really need these. But I'm going to put them here anyway because you're familiar with it. I'm going to do a Control A that selects everything, and a Control I. Control I changes the indent in Eclipse so that it's pretty. So any statement that's inside something, for instance, this for loop is inside the print factors method. Print factors method is surrounded by these curly braces, this one down here and this one, and it tabs it in. So every time you tab in, it's inside the next bit of scope outside. So now I have a printer that should work. I have a fake find most factors that gives me a fake most factors, and I have an input that should work. So this should run, and the print statement is working. Please enter a positive integer, 15, and it prints out 5 is the smallest number that has 5 factors and prints them out. So we have two things working. We have the printer working, we have the get working, and now we have the do math, the hard part. So let's get the do math working. So here's the do math, find most factors, and we want to do two things here. Find most factors, and we want to search for the smallest number that has the most factors. So we needed something to find factors, so we have to find factors. So the most factors means we have to find factors of a number, and we need to compare how many factors this number has with the past most. So we need to save a most. So that's find most factors. And then search for the smaller number means we need to start at the big users number and look at each number smaller and find factors. So here we have a design for find most factors. Do notice that some of these things, find factors, we can use as a function. So let's get this thing. Start at the big user's number. So we do a for loop here. For int, we'll call this what the factor, f equals the user's number, user num, while that f is greater than 0, so 0 will not be factored, and we're going to decrement. And so this will search through all the numbers, look at the start at the big user's number, and look at each smaller number. So we're doing these two lines here with this for loop. And then inside the for loop, what do we need to do? We need to find factors and see if they're the most. Find the factors and compare how many factors this number has with the past most. So this is what we have to do inside the for loop. And so find the most factors of this, find the factors of this number. So we need an array of ints, int array of this factors equals find factors of this number. This number is an F. Now notice find factors is red. We're going to make some magic function that finds the factors and returns them as an array of integers. But we don't have the function yet. So this call to that non-existent function is red. Then we need to compare how many factors this number has with the past most. So I need a most factors back here, and that's going to be this return array. So we're going to compare to see if find factors has more factors than the current return array. So let's make this return array tiny. We're going to have it give it 0 factors. So return array now has 0 factors, and we can see if we have more factors than what's in return array. And the easy way to do that says if the return array length has less factors or equal to factors than the current one, this factors dot length, that means we want this factors and not the old one. And that's very easy to do. We just say return array equals this factors. That's all we need to do. So before we already checked it, and then we had to go and find all the factors again. Here, find factors finds all the factors. Return array holds the smallest number that has the most factors between the user's number and this. It starts out empty. And then we start at the user's number that they gave us. We go down from there. We look at all the numbers between that and 1 inclusive. We find the factors of that number we're looking at, and we see if the number we're looking at has more or the same amount of factors as the one that has the most return array. So let's refactor return array. I can do a refactor. I can change the name because instead of return array, I'm going to call this most factors. And notice when I do a refactor, every time I use return array, it's changed it to most factors. So it changed it here where I created it, changed it here where I used it, changed it here where I returned it. So this makes more sense. And now this should work. The only thing that's not working is find factors. And so we need to do find factors. And we're going to make a function for that. So find factors is a private static. It's going to return an int array. And the name of it is find factors. And it takes as input a single factor. So we're going to find the factors of number f. Or let's call it number n. So let's write down what this does in comments. Find factors finds all factors of the number n and returns them in an array. So we need an array to return this. We'll call it the factors. It's an int array, the factors, and we're going to set this to an empty array. And when we're done with this function, we're going to return it. So let's test this to see if find factors, let's not test this yet. Let's finish find factors and then test it. So to find factors, how do we find the factors? We're going to start at 1 and end at n. And if the number evenly divides n with no remainder, it is a factor and should be added to the array of factors. Alrighty. So we know that every number has at least 2 factors, and so when we're done, the array should be full of factors, but we need something, need a way to add a element to an array. So let's look at arrays and see what we have to play with. To find out what we have to play with, just type the name of an array. We have the factors is an array. If we put a period, we get all the things. We want to add to it. Let's see, we have length equals clone int to int equals Boolean get class. This looks like it's going to be a problem. This is going to be a problem. So we don't know how big to make the array. And so there is something else in Java that will add to the back. Array list. I think it's an array list. So let's do an array list here. And I don't remember how to type it. Let's see. Create class, change object to object, no interface, change to array. Array list, here we go. Change to array list Java. So I didn't know exactly how array lists works. I've seen them once before. An array list acts like it's an array. And then equals new array list, empty. But array lists allow us to, and I need to convert here, add new elements to it. So now we have a whole bunch of new things, and we want to add Boolean void. I think it's this add here. Add object Boolean array list. Let's see what this does. Append a specified element to the end of this list. That's exactly what we want. Add array list, and then we want to, when we put this out, we want it to return an object array to array object array arg0. So it's probably this one, to array. Returns an array containing all the elements in this list in the proper sequence in the object type. So in return, we're going to do Refactors dot to array. And let's see, to array returns a array list. And it takes an array list, let's see, returns array containing all the elements, list proper sequence. Type returns array is specified in the array. If it fits in the specified array, it is returned therein. Otherwise, a new array is allocated. So we don't care if we return it to array. Can I put null here? See if this works. Oh, this might work. Factors cannot be resolved as there is not a field. All right, so something's weird here. Let me figure this out. Otherwise, we have to know how many factors, and then we make an array of those factors. So I'm going to do it the hard way, and then we use these array lists. So I'm going to put it back to an int array. I'm going to do it the hard way first, and then we're going to do it the easy way. So the hard way is, first we need to find out how many factors do we have, and then we create an array for that, and then we return it. So there's 3 steps. So find out how many factors, create an int array of the right size, and then fill in the int array with the right factors. So we're going to be doing things twice here. First is find out how many factors. We need an int count. We call it factor count. Starts at 0. Then we do our for loop. For int n, I have an n. Int I equals 0. I'm sorry, I equals 1. I is less than or equal to n. I plus plus. And then if I percent n, that sees if there's any remainder when we divide I by, or sorry, n slash I, n percent I is 0. If there are no remainder, then we have a factor, fact count plus plus. So the first step is to find out how many factors. Then we create an int array of the right size so that we have the factors equals new int of the right size here is factor count. And then we need to fill this in with the right factors. And so we do our for loop again. For int I equals 1. I is less than or equal to n. I plus plus. And then if n percent I is 0, that means it's a factor. Then we're going to put it in the array. And so we say, oh, I need another integer. Int x equals 0. And we say, this is called d factors of x plus plus equals I. Return the factors. All right, how much time do I have? A minute. Okay, so I'm done with this. I haven't tested it yet. Let me walk you through the thing. Here, we're creating a find factors. This gets an integer and tries to find the factors. It's going to return an integer array. I start with an empty integer array. I need to know how many slots has that array, how many elements. So I have a factor counter. I go through 1 through the number. If it's a factor, I count it. Now I know how many to make, so I can create a new integer array that has the right size. Now I have an array that has the right size. I start an index counter. I go through all my numbers again. If that number is a factor, I put that in the right slot. I then increment the index counter, so this is post increment. So I use it first and then I increment. And then I put the value I in that, and this should return the most factors. So if I run this, it might work. So let's see. 33. Shazam! And we're done.